Hey there, space weather watchers. We've got a coronal mass ejection on the way. Make it 2. In fact, it might even be 3. We'll talk all about it today at the Daily Space Weather Show, the regular feature of the Smash News Network least busted name in news. That's the past 24 hours from the SDO, the Solar Dynamics Observatory. And we're going to take you on a fresh tour right now in this wavelength. There's the full disk view. Here's the southern hemisphere. And you may notice a little bit of a pulse happening in the southwestern limb. That's the lower right at the end of the video. That could be the source of a third earthly directed coronal mass ejection. We've already got 2 on the way for sure, and that last one might be just starting to make its way out into the solar system as we produce this video. So we may have to make another video later in the day today. Here's a great prominence and extension of a southern polar filament just south of that region where a bunch of plasma has indeed ejected. Here's a close-up of that prominentiary filament. And you can see part of that CME popping off right at the end of the video there. Right there. So that was just a couple of hours before we produced this on October 15th. Let's zoom out to the equatorial zoom. And I believe we have at least 1 new sunspot that's already risen. There may be 2, and I suspect a third one is about to rise there in the northeast. Let's take a little closer look at the most recent new sunspot, just to the east, southeast of the Earth scale there. That is already confirmed as a sunspot. Here's a full North Polar view. And there's where there may be a new sunspot rising in the northeast. We've had a decline in solar activity overall. By the way, we're going to talk about cosmic rays, yesterday's annular eclipse, and lots more today. So strap into your strap-on. Wait, don't. Anyway, thanks to our new YouTube subscribers, by the way. Congratulations on realizing the most comprehensive daily space weather show in the known universe exists. Tell your friends and foes, perhaps share with your short attention span pals, family members, neutrals, online peeps. Check out our shorts. Super popular. And, don't forget to press the like button. Yeah, press the like button. Press the subscribe button if you're new to the channel. Do yourself a favor and get the most detailed solar imagery along with our in-depth daily space weather analysis. Have you pressed like yet? No, that's okay. We'll wait. If so, leave a comment. Press the share button. Visit us on social media. And don't forget to visit the links below this very video. A bunch of links are down there, so check those out. Once again, thanks to our new YouTube subscribers, old YouTube subscribers, etc. Thanks to the Smash team, as these videos are brought to you not only at massive personal risk and expense by Smash staff and I, but also from the Smash team. SmashOmash.com/Smash team. Similar to various different highly popular YouTube channels who've created subscription services on their own website, we did the same. We even offer, just like them, complimentary merch for a 1-year paid-up gold membership. So complimentary merch, it's almost like getting 4 months of a gold membership for free. Support the channel via the Smash team. That's the best way to do it. There's a silver level. There's a gold level, a gold annual paid-up subscription level. There's even a bronze level. We send email alerts out about videos like this one for all of those levels because of people complaining about not getting notifications. So we've created solutions to the problems. You have to utilize those solutions. If you're not seeing these videos coming out regularly, that's on you. We send out email alerts. Another place you can support the channel is our Amazon shop. It's amazon.com/shop/smashomash. And if you're disappointed that you don't have a set of Eclipse goggles, head to our spaceware collection over there at amazon.com/shop/smashomash, our Amazon storefront, and pick up yourself some Eclipse glasses. A bunch of different options there, including sets of paper ones, high-quality plastic ones. You can even get our radiation-reflecting bucket hat there, as well as other spaceware regularly featured on the broadcasts. Also in the description, you'll find a link to the Hemp Lucid shop. If you're running out of CBDs, re-up via our Hemp Lucid shop. Perhaps try the water soluble if you haven't. It's the fastest acting and has the shortest duration. Also savings on mushroom gummies. And don't forget the big savings on the stacks. Sleep Immune and stress stacks. All $15 off right now, folks. Huge savings on the full stack as well if you want to pick up all three of those Sleep Immune and stress stacks. Huge savings. The lip balms are now back in stock as well. The Hemp Lucid shop. It's linked below this video in the description. They make great gifts, and they're a great way to support the channel. So those are some of our paid affiliates/sponsors. Thanks to everybody who has supported the channel over the 6+ years that we've made these daily space weather videos. You can find links at smashomash.com to all of that stuff. Smashomash.com, the official homepage that we launched back in February of 2019. And we launched it to dodge all the censorship. So we realized we needed our own site, so we created it. There's a huge web ring there created for people just like you. We are free speech purists. We encourage all legal speech. Yeah, all legal speech is encouraged, not free speech phonies. So, yeah. Smashomash.com, the homepage. Check us out. We're all over social media. Hit up the links. Today's featured product is May That Solar Wind Be At Your Back. Go out and tell your friends and foes and neutrals that you're a space weather enthusiast by sporting this massive 16 megapixel image of the closest star, an SDO image in 304 angstroms. You can even get it printed on the back of your products. Thanks to everybody who's picked up merch and helped to support the channel that way. This one features the homepage, smashomash.com. And in any case, may that solar wind be at your back. Here is the past. That's yesterday plus today from SDO Continuum. And it looks like we've got some degrading sunspots there. So a further dip in the sunspot number. Sunspot evaporating up here in the north. Sunspot shrinking down here in the south. And so, yeah, another dip in the sunspot number. There's the magnetogram for October 14th and October 15th to date. Let's talk volcanoes briefly. Sakurajima is still erupting, producing a 9,000-foot ash plume. I think that's an uptick at Sakurajima. Suwanosejima, 4,000-foot ash plume there. Mount Mayon, unknown volcanic ash plume. 14,000-footer over Semeru. It's a flight level 140 over East Java. Popocatépetl exploding, flight level 210, 21,000-foot ash plume over central Mexico. If you're going on a volcanic vacation, please do not pole vault the caldera. Santiaguito exploding, flight level 150 over Guatemala. Similarly sized ash plume over Fuego. It's a flight level 150 over Fuego. Revenador in Ecuador exploding, flight level 150 as well. 15,000-foot ash plume, 23,000-foot ash plume over Sabancaya in Peru as it explodes. And check it out, another 6+ magnitude earthquake has struck Afghanistan in nearly the same location. This is the past 90 days of earthquake activity. And check it out, in almost the same spot, northwest of the city of Herat, a 6.3 magnitude earthquake struck at 3:36 Universal Time this morning. As if it hadn't had enough damage already, some more damage likely inflicted there. That's the third 6+ magnitude earthquake in Afghanistan in, is it less than a week? Let us know in the comments. I do not remember. It's not my specialty. Here are the rest of the quakes of a 5 or greater magnitude. There's a 5.1 at the South Sandwich Islands. That was at 22:10 Universal Time yesterday evening. And there's that 6.3 followed by a 5.4 magnitude aftershock about 20 minutes later. Bad times for that part of Afghanistan, that's for sure. Here's a 5.2 at Japan a little bit later, 9:13 Universal Time this morning, and also Iran had a 5.3 magnitude quake at 11:15 Universal Time this morning. And let's head back to space. Here's the SDO 304 angstroms wavelength for the past 24 hours. Again, low levels of solar activity here. The 10.7 centimeter radio flux has now dipped to 149 solar flux units. So there is that 1 year graph. The black line is the 10.7 centimeter radio flux. The red line is the sunspot number. By the way, we're going to do a cosmic ray report today, and an interesting feature that I might not have been emphatic enough about when I talked about the only known cosmic ray point source. We'll get to it. Space Weather Enthusiast Dashboard is not forecasting any geomagnetic storm conditions. We could see some geomagnetic activity starting around late day October 17th because of an earthly directed coronal mass ejection. And guess what? There's at least one more. We'll cover that as well. First, let's take a look at Earth's magnetic moment from space. And we've got an extremely low density plasma environment. So this is the plasma density for the past 4 hours. And the blue portions are depicting high density plasma. The white portions are depicting low density plasma. And like I said, that is very low density plasma, as measured by the ACE spacecraft at Lagrangian point 1. Very low density. Solar wind has subsided in terms of the coronal hole high-speed stream. Here is the magnetohydrodynamic pressure, and it is a very low-pressure environment as a result of that extremely low-density solar wind. Solar wind speed also dropping down to below average levels. So the solar wind is extremely diffuse, and it is also quite slow. So when we see CMEs start to arrive on the 17th of October, we can expect to see a significant signal. Earth's magnetic moment from the ground also quite calm here in terms of changes to Earth's B field, otherwise known as geospace delta B. It is geomagnetically calm conditions, very calm conditions, on planet Earth at the moment. The past 4 hours of Earth's magnetic moment from the ground. KP index currently at 0.67. That is your average global geomagnetism there. The planetary K index, again, 0.67. And take a look at the solar wind. Extremely diffuse. Less than 1/3 of a proton per cubic centimeter there. Solar wind density 0.27 protons per cubic centimeter. Solar wind velocity here now dropping below 400 at about 380 kilometers per second. Also, the fields are super weak. Check out the fields. The BT-BZ total field is only 2 nanotesla, and the BZ is +1. Yowzers, that is extremely weak solar wind. GOES magnetometers here are quite smooth, as you may have come to expect if you watch the channel regularly. GOES magnetometers there in a very moderated range with medium lows and medium highs for the past 24 hours. Next, our top view ecliptic plane field plot, and Earth has just snapped into the South Pole current sheet. So there's the latest image. You can see Earth's magnetic field line is now in this red portion. South Pole current sheet has arrived, folks. And it was not a very exciting arrival because not a lot going on. Earth having just recently left the North Pole current sheet, which does include a significant coronal hole high-speed stream nestled in that small current sheet. Anyway, here's our line of sight field plot. Solar B field depicted in blue, North Polar field in green, South Polar field in red, gong magnetogram of the photosphere in grayscale. Which brings us to coronal holes, a super important feature of the solar cycle. They stagnate at the poles at solar minimum. They migrate across the equator at solar maximum. They find themselves attenuated at the poles at the next solar minimum after the fields reverse. When we talk about solar polar field reversals, that's what's reversing, the solar coronal magnetic fields. Of course, sunspot polarity does reverse as well, but really the solar polar field reversal cycle is what we're looking at in the coronal holes. So there's a situation. We've got North Pole coronal holes here in the southwest, and the rest are South Pole-oriented coronal holes. So here are coronal holes in 211 angstroms. So these are north. All of the rest of these are south. Sector boundary crossing is like this. Actually, it's probably more like this. That's the past 24 hours, SDO 211 angstroms. And shall we move on to sunspots? What do you say? Just kidding, folks. It's a dictatorship. Yeah, we run a space weather dictatorship. And remember, a benevolent monarchy is vastly superior to a malevolent democracy. Anyway, there's a sunspot number, just barely over 100 here. And let's see. We should see an, I don't know if we'll see an uptick or not, actually, because some sunspots have evaporated in the past 24 hours, although some new ones are rising. So we may drop below 100 sunspots before tomorrow's daily space weather video, prompting people to run around with their hair on fire and freak out and say, oh no, the sun's shutting down, the sun's shutting down. You'll be fine, folks. The sun is not shutting down. And let's move to the Integrated Space Weather Analysis Center here. There is our flare probability and solar flare scoreboard. Likelihood of large solar flares not so high at the moment. The largest flare producer was actually up in the northeast. That would be sunspot 3467, I believe it was. And let's take a look at sunspots here from SDO. There's 171 plus SDO continuum. Let's subtract it. 171 angstroms. There's SDO continuum by itself. Again, you'll see some sunspots shrinking and some evaporating. The rest of those are fairly stable. Again, at least 2 new groups have already risen, I think. At least 1 new sunspot group has certainly risen, possibly 2. And we're expecting another one to rise in the next 12 hours, farther up in the northeast. So that's sunspots. Next, solar flares and energetic particles. No spikes in the proton flux, just barely tiny little perturbations happening there early in the day yesterday. And as far as X-rays go, only C-class intensifications. So that was a C 9.8, 9.91. I stand corrected. C 3.42 and a C 3.22 are all we've seen for solar flares. And again, those came from the northeastern limb. So interestingly enough, that sunspot is now becoming less likely as it moves closer to the center of solar disk because of the Earth-facing quiet effect. And yes, there are valid physics explanations for the Earth-facing quiet effect. And let's take a look up, since it's been an interesting day for astronomy and so on as a result of a totally sweet annular solar eclipse yesterday. So here's a star chart. This is what's happening over Lehigh Valley, PA. If you want to make your own, head to skyandtelescope.org. Just put in your location. And by the way, if you're viewing the night sky, you'll get a great view of Mars and the moon very close together. A tiny sliver of a moon if it's visible at all. After all, it is new moon. And if you're viewing the morning sky, you might see Mercury quite high, Venus quite high up in the sky there. the third brightest object visible from Earth. Next, a solar system forecast from theplanetstoday.com. There's where things are today. And we'll advance this 1 week as we're wont to do most days on the channel. Here's where things will be on the 22nd. We will be at first quarter on October 22nd. So, annular eclipse, we actually streamed part of it. This is what the annular eclipse looked like from the GOES 16 yesterday. Yeah, the GOES 16 got in on the action. And our Twitch channel and smashomash.com/smash team, the homepage for it, streamed this throughout the day yesterday. There's a little bit of an annular eclipse from space, from the geosynchronous near equatorial orbit of the GOES 16. It was at the right place at the right time. So there's the annular eclipse. Who knew we were streaming it? Well, anybody who tuned into smashomash.com/smash team or the Twitch channel would have seen it. And you can find all kinds of information on space.com, NASA's public relations website. So a bunch of fantastic imagery all over the internet about yesterday's annular eclipse. Again, space.com. We'll show you a brief video here. There are some eclipse onlookers. And NASA got some video from Albuquerque, which we'll show in a moment. And here's some from, where's that? There's Burleson, Texas. Some great little solar arcs there as the sunlight passes through trees, creating a projection of that image. That's the astronomy photo of the day. If you want to check it out, astronomy photo of the day at apod.nasa.gov. And here's some imagery from Albuquerque, streamed yesterday by NASA. So that is what it looked like. Great imagery there. And here's some imagery from one of our viewers. Shout out to George of the Jungle. Yes, we had some images sent to us. If you haven't checked out our community posts, check those out. We do share all kinds of stuff. Some stuff not even related to space weather on the YouTube channel. Again, shout out to George from Costa Rica, showing some great images of that annular eclipse. Now let's talk about cosmic rays. Yeah, cosmic rays. So, cosmic rays are kind of important because they affect Earth's weather and indeed climate. So, there are very few. In fact, there's only one known cosmic ray point source. It's this high mass X-ray binary known as Cygnus X3. Now, these are the hard X-ray emissions from Cygnus X3. So Cygnus X3 is bright across all portions of the electromagnetic spectrum, but it's also a cosmic ray point source, meaning it sends particles all the way to Earth from 37,000 light years away, all the way on the opposite side of the galaxy, sort of. It's like 1/3 of the way across the galaxy. And Cygnus X3. If you want to follow the hard X-rays from it, head to the Neil Gorell's Swift Bat Hard X-ray Transient Monitor. And you can monitor all kinds of objects from there, whether you want to monitor the galactic core, Sagittarius A star, Cygnus X1, the closest, quote, black hole, or the strongest X-ray source from the constellation Cygnus, the Crab Pulsar, over 1,000 objects visible there from Neil Gorell's Swift Bat X-ray Observatory. Entry number 952 is Cygnus X3, the high-mass X-ray binary in the constellation Cygnus. It's only the third brightest X-ray source in Cygnus. However, it is the most bright intrinsic X-ray source in the entire universe, at least from our perspective. So anyway, it's also the only known cosmic ray point source. It has a very interesting periodicity of 4.79 hours, and it's an eclipsing binary, meaning it has a more massive object that is orbiting a normal sun-like star, and it's anyway, it's a cosmic ray point source. The more massive object has one of its polar fields oriented directly toward Earth. And here's what's interesting about this. Now, as many of you who understand physics may already know, photons move faster than protons through space. And as you can see here, Cygnus X3 is currently at the highest X-ray output just for the past year or so than has ever been measured over about 18 years. So that is interesting because perhaps Cygnus X3 has a preceding X-ray output. This is a logical conclusion, folks. It goes into a higher state of activity. Perhaps it has a higher X-ray output before we receive cosmic rays. Now, here's the thing. We don't know if those cosmic rays take 1,000 years longer, 10 minutes longer. I mean, it's obviously over a year longer because we haven't seen a huge increase in cosmic ray flux. So we just simply don't know. It could take 10,000 years longer for the actual particles to arrive. As remember, folks, cosmic rays are particles, and these are X-rays. So anyway, that is an interesting feature there. The highest levels of X-ray flux ever measured at Cygnus X3, over 18 years of constant monitoring there by the Neil Gehrels Swift-Bat X-ray Observatory. So that said, if you want to read more about Cygnus X3, you can check it out on the forum, smashomash.com/forum. There's a cosmology forum there, and there's an entire thread just about Cygnus X3, the massive X-ray binary in the constellation Cygnus, the brightest X-ray source, intrinsic X-ray source, that is, in the entire sky. And let's move on to do the cosmic ray report. So we're going to do a cosmic ray report here just because we're seeing such low levels of solar activity. We want to see what's going on with cosmic ray flux. So we're going to show over 7 different monitors, and these are in alphabetical order, starting with Apatity. So there is Apatity, and a small uptick in cosmic ray flux over the past 30 days at Apatity. Barentsburg is next, and a downtick there at Barentsburg. So the average of those two is largely flat over the past 30 days. Next, we'll go much farther south to Athens, Greece, which is very flat over the past 30 days. So that's Athens. And did you know the cosmic ray flux is inversely proportional to sunspot number? Yeah, cosmic ray flux. When we see high cosmic ray flux, we see low sunspot number. In other words, it's inversely proportional to solar activity. High cosmic ray flux is associated with solar minimum. The lowest cosmic ray flux ever measured is associated with solar maximum. Here's Mexico's Cosmic Ray Observatory. Very flat there at Mexico over the past 30 days as well. That is Mexico City's Cosmic Ray Observatory. And next, heading to Oulu. There's Oulu, Finland. And what's great about this cosmic ray station is it dates all the way back to 1965. And so you can see every solar cycle here represented. There is the solar maximum there's solar maximum solar cycle 24, there's solar maximum 23, 22, 21, and 20, all represented perfectly on that graph. Oulu, Finland, slightly down in cosmic ray flux, almost flat over the past 30 days. So now, also, if you look at this graph, look at this area right here. Cosmic ray flux is currently at the lowest level since 2004. So if there are YouTube channels telling you that the energy from space is increasing and increasing, let me bring this graph back, folks. Does that look like the, quote, energy from space? First of all, nothing should be called energy from space. That is what pseudoscientists say, energy from space. It's cosmic ray flux. This is a neutron monitor. It's measuring neutrons because those particles cause atomic nuclei to be smashed apart because they're traveling at such a high rate of speed that when they reach matter on Earth, they blast it to pieces, cause particle showers, and all kinds of secondary particles come to exist as a result of that cosmic ray flux. Lowest level since 2004. And you can expect the levels to continue to dip because, look, When has a solar cycle just come back up? All right, so look at that. There's that graph. A third grader could understand why this is likely to continue to dip, or at least level out at this level. Lowest levels of cosmic ray flux since 2004, folks. These are facts. Energy from spooky energy from space is not increasing. And this solar cycle could indeed exceed solar cycle 23. So anyway, that's the Oulu neutron monitor. Slightly down, almost flat over the past 30 days. And let's go as far south as we can get. By the way, Oulu is located in Finland. There's DOMB Antarctica, slightly down over the past 30 days. And there is DOMC Antarctica, also slightly down over the past 30 days. So those are facts. This is not a forecast for increased cosmic ray flux, all right? We do see that high X-ray output from Cygnus X3, the only known cosmic ray point source. But we don't know how far behind. It's likely that that X-ray flux is associated with more cosmic rays from Cygnus X3. However, we don't know if those cosmic rays are 10 years, 100 years, 1,000 years, 10,000 years, or 36,000 years behind the light emitted from Cygnus X3. Because remember, folks, X-rays are light. So similar to the way solar flares are not coronal mass ejections, X-rays are photons. Cosmic rays are protons. Just like solar flares are photons of the X-ray category, and coronal mass ejections are protons. In other words, gas, physical particles, mostly hydrogen nuclei. And cosmic rays are composed of the same material that the solar wind is composed of, mostly hydrogen nuclei, followed by helium, and then electrons, and then heavier elements. Let's get to coronal mass ejection since I brought it up. We don't have any data from the GMU, unfortunately. The last 3 days there are blanked out. So no computer interpolation there of Velasco C2. So let's take a look at C2 plus C3. And here, right at the end of this video, you're going to see... All right, I stand corrected. Anyway, here are yesterday's CMEs. So that one coming out of the southwest, that likely has an Earth-directed component, a significant Earth-directed component. You may even see a halo-like eruption there. We're going to let that play through in its entirety a second time. We've got the C2 slightly ahead of the C3, so the imagery on the left, watch that first, then look on the right. You can also see Mercury over there on the C3. So the C2 has now reset. It's several hours ahead of the C3. So right in here, about 1700, you're going to see that CME coming out of the southwest. That has an Earth-directed component. So starting on October 17th, sometime late in the day, you can expect the earlier CME to arrive. And then we're going to have a few days of coronal mass ejection impacts once again. So there you go. There's the C2 and C3. Let's bring this, I'm going to bring this back to that latest earthly directed CME. And again, there might be another one occurring as we make the video. So we may have to make another video today about that. There is that CME. And if you look on the C3, you can see a bit of a halo coming out there. That is an indication that a large portion of that is directed toward Earth. So that'll arrive likely sometime early in the day on the 18th. Again, we are expecting one late in the day on the 17th as well. Let's see a bunch of plasma coming out there. So at least 2, possibly 3 coronal mass ejections headed our way. We'll also show it from Stereo A's perspective. So there's yesterday's first CME. That one will arrive sometime late in the day on the 17th. And there's the second one. And unfortunately, we've got limited data there on the coronagraphs. So let's just bring that back to show you the still image. And there's that CME propagating. Likely to be largely earthly directed there, although most of the material will miss actually to the southwest. So there you go. At least 2 CMEs already headed our way, and possibly a third one ejecting as we make the video. Next, our custom coronagraphs. There is SDO 193 angstroms. as well as the Soho-Lasco C3 in blue and the C2 in red. Also Mercury there moving into view. And there is a fantastic view of the latest available in the data earthly directed coronal mass ejection. So now, and then there were two headed in Earth's direction. So that one came out of this active region right up here in the northwest. Here's an even closer view of that, and we've subtracted the C3 and added 304 angstroms. So the most recent event, I don't suspect this most recent one is going to be earthly directed because it's pretty far down here in the southwest. You can see a little bit of a hider flare happening there right at the end of the video. That is the most recent CME. I suspect that one will miss Earth to the southwest, but it's too early to tell as we do not have coronagraphs yet for that. And before we get to filaments, we'll zoom all the way in on those wavelengths. 304 plus 193 angstroms SDO, the Solar Dynamics Observatory. So quick summary, at least one new sunspot rose, I think probably two, and likely three in the coming 12 hours. Next it's time to cut to filaments. Oh hey, check it out, here's an even closer view on those wavelengths. Sometimes we make so many videos, custom videos, that we forget. So there you go. There's a spectacular image of the closest star. Brought to you by the Smash News Network, least busted Dave. In news. Cerro Tololo, Chile had a little bit of an annular eclipse yesterday as well. There you can see the moon moving across the frame there. And another massive filament here in the southeast. Check that one out. That's a good one, deserving of a name for sure. The Cerro Tololo, Chile, ground-based hydrogen alpha telescope. And if you want to name that filament after your friends, your foes, or even yourself, go join us over on Twitter. Thanks to our new Twitter followers there at x.com/smashomash. Follow the hashtag NameThatFilament. And there are filaments in grayscale from the same ground-based hydrogen alpha, Cerro Tololo, Chile telescope. And you can see that prominence that we showed to kick off today's daily space weather video. And let's hurry up here as this video is getting kind of lengthy. There are the past couple of hours from the GOES 16 SUVI. Which brings us to bonus features. First, satellite charging hazards. We ain't got none. It's smooth sailing. No high energy electrons inside spacecraft, and no low energy electrons on the outsides of spacecraft. GOES electron flux remains low, and we are expecting a big uptick in the electron flux in the coming days. There's the 1-year graph of the relativistic electrons. Still cratered here. We're expecting a rapid uptick. NOAA agrees. There's NOAA's forecast for a greater than 2 mega electron volt electron flux measured at the F layer of the ionosphere. And here's the layer where it's measured in vibrational frequency, the F layer, courtesy Australian Government Bureau of Meteorology. Here's another view of the F layer, the anomaly in megahertz from a 30-day median. Spring has arrived for the southern hemisphere, so you can expect to see more scintillation at the South Pole than the North when we do see geomagnetic storm activity. And indeed, you can see more low-frequency anomalies happening down there at the southern polar region. You may have come to expect this, especially if you understand the physics. So anyway, that's what's going on in the ionosphere, the raw data, and the anomalygram. There's the latest image, 13:45 Universal Time, coming at you a little late today. And there is the anomalygram, also 13:45 Universal Time. We'll also show the WHAM, the whole atmosphere model, depicting electron content and maximum usable frequency. Very useful for radio and GPS operators. WHAM, that's the whole atmosphere model. That's the ticket. And we'll also show total electron content by itself. There's the full globe view. It's still looking weird. I don't know what's going on with the total electron content forecast. I think there's a problem with one of the data sets or something. It looks jacked up. Let's switch to the North American total electron content anomaly from the 10-day average. And your GPSs are looking like they'll be pretty clear here. Not a lot of major anomalies there over North America. Last but not least, let's take a look at these new sunspots, or at least one new sunspot group. Before we get to meteorology. So scrolling up the eastern limb here. So there's one new sunspot for sure. That one right there. That right there looks like a plage, so that's not a sunspot yet. And there is another likely one rising. So one little pore rose there over the eastern limb. Likelihood of flares, large flares, not all that high. I mean, I would say the most likely place to see a large flare would be right here in the western limb and up here in the northeast. So quite low levels of solar activity here in the past 24 hours. And let's move to meteorology. I figured out over 20 years ago it's too easy to forecast the weather. It's all about understanding the physics once again, folks. So you too can forecast your own weather. We empower our viewers to do just that. We're looking at sea surface temperature anomaly and surface winds. As we forecasted a few days ago, a strong low has formed off the coast of New Jersey. Although it is over a bunch of cold water there, so it's having a little bit of trouble getting organized. So it's going to move up to the northeast, where there's some warmer water there, and it might actually intensify a little bit, although the water is not really that much warmer. It's just anomalously warm for this time of year. See, there's the raw sea surface temperatures. So there's the sea surface temperature anomaly. There's the raw sea surface temperature. And we're going to show sea surface temperature anomaly for the whole planet. So there's the North Atlantic. Let's zoom out a little bit here and show the Arctic Ocean. There's the Arctic Ocean, a mix of warm and cold water. There is the full Atlantic Ocean view. Southern Ocean. The Indian Ocean. And the massive, massive body of water known as the Pacific. And let's talk air masses. Yeah, air masses. That's usually what you talk about with meteorology, right? There are the surface winds of the east. These are the jet streams of the east. The jet streams of the central world. Surface winds of the central world. Surface winds of the west. And the jet streams. Powerful jet stream convergence happening over Texas as cold air moves into the central U.S. It's headed east. We'll tell you all about it. Next, our windy.com pressure map. That is mean sea level pressure. You know, barometric pressure, atmospheric pressure, whatever you want to call it. Here are clouds and fog. Did you know you can see clouds and fog even at nighttime using the shortwave radiation satellite? A lot of low clouds over the central U.S. Here's that low that's formed off of New Jersey. As you can see, it is indeed moving to the northeast. And here is our weather.gov map. So a bunch of freeze watches there, freeze watches and warnings over the south central U.S. Get your weather warnings at weather.gov. Weather.gov. Those are too many counties to cover. However, we can show you some forecasts. So tropicaltidbits.com, providing these GFS model forecasts there. That's the jet stream forecast. Again, cold air is sweeping across from west to east as the jet stream injects a strong Canadian air signal there. That's the jet stream forecast. Here is your temperature anomaly forecast in degrees Celsius. Another 72-hour forecast there. Colorado, it's having a peak of hot air once again. Oh, look at that. 72 hours from now, Colorado will have even hotter air than it has now. Who could have guessed, besides our regular viewers? So much hot air. And next, pressure and precipitation. The 72-hour GFS forecast thereof. So there you go. That's what's going on. Next, lightning. Give me the full screen view. There we go. There's where lightning's been striking over the past about 10 hours. And here's a real-time lightning map. What the heck is going on? There we go. And we've got about 410 strikes per minute here on the global scale. Some individual strikes there in the Atlantic Ocean. Central America and southern Mexico seeing some lightning, as well as northern Italy. We'll close this thing out with U.S. Doppler radar, clouds and fog, and water vapor. That's what's going on for the full 50-state view. There's the lower 48 view. As we zoom in all the way from the closest star to the contiguous U.S. Look at all those low clouds over the central United States. There's a water vapor map. That should help define your Doppler if your Doppler is unclear. For example, if you want to know what's going on in Missouri there with those scattered showers, break out the water vapor map. Anyway, there's the clouds and fog view once again as we close out this video with our recap. And there's that water vapor map as cold air intrudes from Canada, making its way east. Anyway, it's time to close this thing down. Thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing it exists. We remain surprised that you have, thanks to our new YouTube subscribers. If you're new to the channel, press the subscribe button. If you're old to the channel, if you're viewing the video, period, press the like button, share, comment, etc. If you're mad about the forecasts, tell us all about it in the comment section. And we'll see you soon. In the meantime, may that solar wind be at your back.